Hello students, now we are going to learn about isoelectronic species. This is the new term introduced in class 11. What is the meaning of isoelectronic species? That we have to see the definition: atoms or ions that have same number of electrons is known as isoelectronic species. Means here the atoms or ions which have same number of electrons are known as isoelectronic species. Now these are the different ions, whether it will be positive or negative ion, or the neutral atoms also. We are counting completely for positive, negative ions and neutral atoms also. But they must have same number of electrons. This is the condition for identifying isoelectronic species. Now I have taken here the example number 1. In this example number 1, I have written one list that N3 minus, O2 minus, F minus, Ne, Na plus and Mg2 plus ions. Right? So here nitride ions, oxide ion, fluoride ion, neon atom, sodium ion and magnesium ion. These all are present in this list. Now, these are isoelectronic species. How they are isoelectronic species? Just we will see the explanation. See, nitrogen is having atomic number 7. Everybody knows. So, 7 atomic number, what it indicates? That it is having 7 electrons. Now, when nitride ion is formed, N3 minus. So, 3 minus charge indicate that it has gained 3 electrons. So, now, the total number of electrons in N3 minus ion is 7 plus 3 is equal to 10 electrons. Right? Same way, oxygen atom having atomic number 8 contains 8 electrons. But when it gets converted into oxide anion, then it will gain 2 electron more. So these 2 electron I am adding over here. So 8 plus 2 is equal to 10 electrons. Same way, fluorine having atomic number 9. But when the fluoride ion is formed, it gains 1 electron. So I am going to add that electron. 9 plus 1 is equal to 10 electrons. So now nitride ion contain 10 electron, oxide anion contain 10 electrons, fluoride anion contain 10 electrons. When we come for the neon atom already having the atomic number 10. Means already in the neon atom 10 electrons are present. So neon atom also contain 10 electrons. Now when we are coming to the sodium ion is obtained from sodium atom, but here now positive charge is there. So positive charge means there is a loss of electron. So sodium atom having 11 atomic number contains 11 electrons. Now when it is carrying one positive charge indicates that it loses 1 electron. So sodium ion is formed by losing 1 electron. That is why it is carrying one positive charge. When we are going to calculate the number of electrons in sodium ion, we have to subtract 1 from 11. So 1 electron is lost. So 11 minus 1 is equal to 10 electrons. Now the next example is of Mg2 plus ion. Magnesium having atomic number 12. Now when magnesium atom contains 12 electrons, it is a neutral atom. But it is when carrying 2 positive charges indicate that 2 electrons are lost by magnesium atom. Now to calculate the electron number in magnesium ion, we are deducting 2 from number 12. So 12 minus 2 gives 10 electrons. So that way you are getting that positive ion of sodium or magnesium, they are also having 10 electrons in them. So ultimately nitride ion, oxide anion, fluoride anion, neon, sodium ion, magnesium ion, all are containing 10 electrons. It is the same number. So they are all isoelectronic species. Now the another example I have taken here, this P3 minus ion, S2 minus ion, Cl minus ion, Ar, K plus ion and Ca2 plus ion. So here when phosphorus we are talking about, phosphorus atomic number is 15. P3 minus ion formed by gain of 3 electrons in the phosphorus atom. So 15 plus 3 is equal to 18 electrons. Now when we are talking about sulfur, atomic number is 16. S2 minus ion is formed by gain of 2 electrons. So 16 plus 2 is equal to 18. When we are talking about chlorine, atomic number is 17. So when Cl minus ion is formed, 1 electron is gained. So 17 plus 1 is equal to 18 electrons. The next term is argon. Argon is having atomic number 18. Atomic number 18. So atomic number 18 means already there is number of electrons 18 in the argon atom. Now next is potassium. Potassium having atomic number 19 means 19 electrons are present in potassium. So potassium ion is formed by 1 electron lost from the valence shell. So when 19 minus 1 we did, then we are getting 18 electrons. Same way calcium 20. Calcium 20 means atomic number 20 indicates that there is presence of 20 electrons in the calcium atom. Now when Ca2 plus ion is formed, Ca2 plus ion is formed by loss of 2 electrons from the valence shell. So 20 minus 2 is equal to 18. So this way you are getting all these positive and negative ion including argon are containing same number of electrons, that is 18. And therefore as their number of electrons same, they are also isoelectronic species. Clear?